First of all, we will see what is the classification of solids. So solids are 3D objects. So we classify the solids basically in four parts. First is polyhedra, solids of revolution, frustum of solid, and truncated of solid. So polyhedra covers prism, pyramid, cube, tetrahedron. Solid of revolutions in which there are cylinder, cone and sphere. Frustum of solid means when a full solid is cut by a plane which is parallel to its base, then the bottom part of the solid is known as frustum of solid. And truncated solid means when any full solid is cut by a cutting plane which is inclined to its base, then the bottom part of the solid is known as truncated of solids. In this figure, I have shown one frustum of solid. This is actually frustum of square pyramid, and for example of truncated solid, here this is known as truncated of cylinder. Now what is polyhedra? So the solids which are bounded by planar surfaces are known as polyhedra. And solid of revolution means the solids which are generated by revolving a planar surface about a fixed straight edge are known as solids of revolution. So let us see the example of polyhedra. This is prism. What is prism? It is defined as a solid which has two identical bases parallel to each other and bounded by rectangular planar surface. Let us see square prism. So this is a solid in which the bottom surface is square and the top surface is also square. So in all prisms, the base and top are same and the lateral surfaces are always in rectangular shape. So here in this square prism, this bottom square part is known as base. Top square surface is known as top of the square prism. Then the side of base, it is also known as edge of base. This is top edge. Now the corners at bottom, there are four corners in square prism. So it is defined as base corner. Similarly, top corners. Now the line joining from top corner to bottom corner, that edge or that side is known as longer edge. The rectangle surfaces which are bounded at lateral is known as rectangle face. Now the center of top and center of bottom or base center are connected one imaginary line. That line is known as axis of the prism. So this is the terminology of square prisms. We must know the information of all the lines in prisms. Now let us see another example of prism. This is hexagonal prism and another is pentagonal prism. So in hexagonal prism, the bottom shape is regular hexagon, top surface is also regular hexagon, and there are 6 rectangle faces. In pentagonal prism, base pentagon, top pentagon, and lateral surfaces are in rectangle shape. So in pentagon there are five lateral surfaces, and in hexagonal prism there are six rectangle faces. Now what is pyramid? So it is defined as a solid having planar figure as base and number of triangle faces meeting at a point known as vertex or apex. The imaginary line joining vertex to the center of base is known as axis. So let us see one example regarding triangular pyramid. So this is pyramid in which the base surface is equilateral triangle, and from three corners a line intersect at one point. That point is known as apex. So here for square pyramid, base is square and there is one apex connected to all the corner of base. So this is a square base, base edges or side of base, base corner, slant face, slant edge, apex, base center, and the imaginary connection from base center to apex, that is known as axis. In all pyramid and prisms, the angle between the axis and the base is always 90 degree. So this type of solids are known as right solid. But in oblique solid, the angle between axis and base are not 90 degree. Pentagonal pyramid. So base regular pentagon, and there are five triangle faces. In hexagonal pyramid, base regular hexagon, and there are six triangular faces. Now keep in your mind, in all prisms, lateral surfaces are in rectangle shape, and in all pyramids, lateral surfaces or faces are in triangle shape. Now, another solid cube. It is defined as a solid in which two square bases are bounded by square surfaces. So it is a solid having six square faces. Cube in which the edge of base or base edges, top edges, and the edge of face, and there are six square faces including base. This is one example for cube in which the center of top and center of base, the imaginary line is known as axis. Another example, tetrahedron. It is defined as a solid having four equilateral triangle surfaces. So it looks like a triangular pyramid, but in triangular pyramid, the length of edge of base and length of slant edge both are different. But in tetrahedron, the base is equilateral triangle and faces are also in equilateral triangle. So axis from apex to center of base. Cylinder. It is defined as a solid generated by revolving a rectangular surface about one of its side which remains fixed. So solid cylinder in which base is circular, top is also in circular shape, and the lateral surface is curved. So here bottom surface in which this line or the profile is known as periphery of the base. This is periphery of top, center of base, and the imaginary line that is known as axis. Now what is cone? It is a right angle triangular surface is revolved about its straight vertical edge. Then generated solid is known as cone. The imaginary line joining its apex to the center of base is its axis. So here cylinder and this cone are the example of solid revolutions. So solid is made when a right angle triangle surface is revolving about one side fixed. Then the volume covered by that surface during one revolution is known as cone. In this cone, always the base is circle. The center of base and apex is connected by axis. The line from apex to periphery of the base is known as generator. So there are a number of generator available in the cone apex. This is base center. Now sphere, when a semicircle is revolved about a straight edge, then generated solid is known as sphere. So to draw the sphere, we need a radius or diameter of the sphere. Now, before starting our drawing of projection of solid, we have to know the basics of position of the solid with reference to HP and VP. So when we observe the object orthographically and when we look the front view, at that time the horizontal plane looks a line. So for front view XY is horizontal plane or XY line. So here XY is horizontal plane. The first position when if you take a solid cone is resting on HP like this. So standing on HP on its base means the base of the cone is in HP and axis is perpendicular to HP and parallel to VP. So at that time your front view looks like this. If it is resting on HP on one point of base circle. So in first case, the point on periphery of base, all the points on the periphery of base is in HP, but in this case, only one of the point of its base circle is in HP. So we must incline this base with horizontal plane. So if you incline the base with HP, the axis is also inclined. So this is axis inclined to HP and parallel to VP. If a cone is lying on HP on one of its generator, so in this case, one of the generator is in HP. Okay? So in that case, the front view looks like this, and in this case, the axis is also inclined to HP and parallel to VP. So these three views are front view for different position of the cone. Now, when we observe the top view at that time, the vertical plane looks XY line. The position on vertical plane means the cone is standing on VP on its base when the axis perpendicular to VP and parallel to H. Here this axis is perpendicular to XY means axis is perpendicular to VP. So this is top view. Second position for top view, if the one of the point of the base is in VP. So axis is inclined to vertical plane and parallel to HP. That's why the top view looks like this. And third case, when one of the generator is lying on VP, the axis is inclined to VP and parallel to HP. So this is basic of position of the solid with reference to HP and VP. So in next lecture or next video, we will discuss more problems regarding position of solid. So thank you very much for watching this video.